Okay, so let's look at a problem where we're dealing with viscosity. So we're going to do this couette flow of a moving plate against a fixed plate. And so we have a 1-inch layer of water that's at 60 degrees Fahrenheit. It's sandwiched between two plates. The upper plate moves with a velocity of 10 feet per second. And so what we want to know is what is the shear stress that's applied to the upper plate. So the first thing that we know is, well, we have a velocity and it's 10 feet per second. We know that we have water at 60 degrees and we have a gap of 1 inch, and we'll call that h is our gap of 1 inch. So we only really have one formula that relates shear stress to fluid, and that's tau is equal to the viscosity du dy. So we're going to need that velocity, we're going to need that viscosity, which we are going to have to go look up. And so if we turn to our textbook or engineering manual, we can find that water at 60 degrees has a viscosity of 2.34 times 10 to the negative 5 pound-second per foot squared. Okay, and so du dy, that is the amount the speed changes with relation to y. It's basically the slope of that line. So the slope of that line du dy, because the other side does start at 0, is just going to be velocity divided by the gap. And so that's your rise over run. So our velocity is 10 feet per second. Our gap is 1 inch. Taking a look at that, that's not going to work out correctly because we've got feet on one side, inches on the other. So let's convert everything over to feet. So we're going to multiply that by 1/12 foot over inch. And so now what happens is those inches cancel out, those feet cancel out, and we will end up with inverse seconds for our slope. And so what we're going to have is 120 inverse seconds. So let's now plug everything in. Our shear stress is 2.34 10 to the negative 5 pound force second per foot squared. We're going to multiply that by our slope, which is 120 inverse seconds. Units are going to break down to pounds per square foot, which is what we do expect with a stress unit. And that gives us 2.81 times 10 to the negative 3 pound force per foot squared. We'll just box that answer. Now, one thing to note, it's a shear stress, and it's going to oppose the motion of fluid. It's actually what causes resistance in pipes, which we'll talk about more later in this course.